What is up, most distinguished patrons of this channel? Today I have a repair video for you guys. I was digging through my phone and found some pictures from a number of months ago dealing with this repair and thought, well, why don't I put together a compilation of the pictures and talk about the repair job that I did on this. And what you're really looking at is basically a hydraulic cylinder or a ram mount for a packer blade on a garbage truck. This repair took quite a lot of time, surprisingly, and I'll walk through each step of it so we're all on the same page and we can all learn something from that. So with that said, let's get into it. So here's a picture of what we're dealing with. That packer blade is that big steel wall in the back of a garbage truck. This appears to be mostly identical to the one I repaired. You can see those two hydraulic cylinders that come down from the up top and then hook up to the packer blade. Well, guess what? One of those mounts there for the cylinder eyes broke clean off, and there's a number of reasons why. We'll find out as I go through what defects I found and reasons why I thought that it probably failed. So this is going to be quite an interesting video because we're going to learn a lot about failure analysis along with how to properly make repairs on stuff that is more or less higher liability or higher strength requirements. So right away, here is the driver's side. This one was completely intact. I found no cracks or defects on this arm, more or less, so that looked good. And let's take a look at the one that's broken. So the passenger side had ripped clean off. And when I say clean, I mean obviously it's a jagged tear, but for all practical purposes, it's a clean break. And that's far better than if it was jagged where pieces of metal were 2-3 inches up and down. That can be a real pain to try and fix. Don't get me wrong, this is a real big ordeal to try and clean this up good enough to make a lasting repair. And when you see what else is kind of screwed up with the engineering of this, you'll understand why trying to make a permanent repair on this could be an issue. One of the things that I noticed right away upon investigating this problem is that the hopper on this garbage truck was full of furniture and bed frames and all sorts of stuff. This is an older truck. It was used for like bulk pickup, and my guess is it broke when the operator of the truck put full hydraulic pressure down trying to crush all that steel, and like there was even a dresser in there, and basically all that force had to go somewhere, and being an older truck that has a whole lot of fatigue steel in it, guess what? It broke off. So step one was to pull the bolts out of that retainer plate and remove that broken ear, or basically the arm, off of the ram and set it up on the bench and start prepping it. That brake, I mean, don't get me wrong, it's crap, and no, you should under no circumstance just re-weld this back on. But all things considered, once I torch cut all of this off to clean metal, it's actually not that bad of a situation. I've had to deal with like shattered steel before where it's a nightmare because you got to cut, 4 inches up just to get the clean metal to do a tie-in. This is actually not best case scenario, but far better than you would expect. The interesting thing here is that it's 1/4 inch sidewalls in a back plate on that, so it faces the back of the truck. And that thicker material that you see at the bottom of the picture, that's facing the front of the truck. And I find it kind of funny because that seems like awfully thin material for the amount of force that this was expected to handle. I mean, 1/2 inch, maybe it was 5/8 plate. It looks like 1/2 inch to me because it's cut at an angle, looks thicker than it really is. But to me, this steel is undersized for the task at hand. And the way that they welded it together really contributed towards why this failed. And I'll show you some pictures that explain what I mean by that. But we need to take this sucker, draw some lines on it that are reasonably straight, and torch cut all this bad material off. I found it interesting that it appears as that this was welded from the inside to complete it, and then somehow they attached it, but the way that it was put together, I'm not really sure how they did that. They might have actually welded it together after it kind of was assembled on the blade. I'm not sure. But anyways, that back wall there has zero penetration. They more or less just ran a stringer weld on it and called it good. And well, there's zero fusion there. Now that isn't really a stress component due to how the force is applied to this, but I just find that kind of funny because, okay, you're going to weld the inside of it, but you don't weld that. I don't know, weird. Here's an up close of the corner there, and you can see that poor grain structure. There's still cracks in there. All of that's got to get torch cut off. I know a lot of people would just slap this thing back on with a minimal grind job, put a bunch of 7018 passes in it and call it good, maybe plate the outside. And you know what, that's fine, you can do that. But honestly, if you want it to last, that's not the way to go. So here I did an initial cut just to get some of the crap off and to look at what the steel behind where it kind of broke off looked like, to see if it had like poor grain structure or holes. And this already looked pretty good, even though I was only about 3/4 of an inch, maybe a little bit more in. So at that point I established a square line using a square, and I'm going to take a cut and cut straight across that with a torch and basically get it prepped to where it's approximately where I would want it. Now keep in mind, anything that you remove off the height of this has to be replaced somehow. So gouging 4 or 5 inches off of this and the bottom part that's still on the packer blade isn't really a good solution, because now you're going to have to tie the two together with a 4-inch gap. I took this picture a while ago to kind of demonstrate what can happen when you bend steel far beyond its yield point. And a lot of people think you can just heat up bent steel with a torch and bend it back and everything's fine. Well, yeah, in theory that might work, but take a look at this. This steel, which is made out of the same kind of steel as that packer blade was, well, guess what? It was bent too far, and yeah, if I torch heated this, I could bend it back straight and it might seem okay, but all those internal cracks, those heating it up isn't going to fix. And that's why you're best off torch cutting or grinding or finding some way to remove the material in any area that was stressed heavily, that broke and has fatigue cracks. You got to get rid of that stuff, because if you just weld over that, what do you think is going to happen? It's going to crack again. So here we go. I took a real nice cut off that thicker piece that faces the front of the truck. And I don't see any evidence of like cracks on the inside. I did find porosity in the factory welds, because this plate was more or less welded to the back side of the packer blade, and it looked to me like their welds had porosity. So that was a contributing factor as to why this broke, was basically piss poor welds. But this material cut back about an inch seems to be pretty solid. And at this point, I just need to rough it up with a grinder, I guess, because this is as cut with a torch. Speaking of torch cutting, I'm not really an expert at it, but one of these days I got to do a video series on how to do that. Maybe this winter I'll spend some time and do that. This steel actually cut really clean for not burning the paint off and being, I don't know, used for 10, 15 years, full of dumpster juice, garbage juice. It cut pretty clean, but I got a decent cut on all sides of this. I only have that bottom part of the picture left to cut. And here's a finished surface all cut with the torch looking really good. When you do a decent job with the torch, it's really not that hard to go back and buff it with an angle grinder to clean the whole thing up. So it really pays to be halfway decent with a torch. Now this is a job you could have done with an angle grinder, but man, I get sick of the time it takes, the risk of the discs blowing up, and all that dust. Like, it's just miserable. A torch is far easier, or even a plasma setup would have been better than using a torch like I did. Here's a picture of what it was all finished ground up. I put a little bit of a bevel on it, nothing really too major, and this is all prepped and ready for welding. Now we need to start on the other side that's still on the truck. So this part is still on the packer blade, and it broke off about 1.5 inches above that side supports there, so we don't have a whole lot that we can cut off. One of the benefits to having that there is I can use it as a guide for the torch to kind of help me cut a straight line. You got to remember that I left this on the truck. Some of the other guys told me that repaired these in the past that they would pull the whole packer blade off the truck. And I'll be honest, I didn't know how to do that. And I felt that I could competently repair it without removing the blade. And looking back, I still think I made the right decision, but depending on how long it takes to actually remove that packer blade, that might have been the right decision. Hard to say. So this looks a little bit lower than it actually is. Crappy camera work on my part. But we're going to clean all of that off and bring it down pretty close to the side supports there in order to get all that rough material out. I will also be plating the sides of it for extra support and strength just to make sure that this doesn't fail in the future again. And here we go after a torch cut. This steel, I'll tell you what, cut really clean. I didn't have any dross on it, which is pretty uncommon. Who knows, maybe this isn't just like A36 hot rolled steel. It might be something else, but man, did it cut clean considering paint and all that grime and rust on it. It's completely ready to be flattened out with an angle grinder. I'm actually not going to bevel this too much. I'm going to run it with a 90-degree joint angle, and I'm going to actually do a bunch of TIG welding on the root on this, which I know is a little bit unconventional for something like this, but due to access and just the way that I had to do this to keep the same height as it was, I didn't really have too much of a choice. I'm good enough at stick to where I could have definitely still done the root pass with stick, but TIG was available to me, so I chose to do that for the root pass. So anyways, I put the prepped up upper arm on it, used a couple pieces of metal as shims, and then used a level to kind of get an eyeball picture of where this thing needed to be. I took a couple measurements of what the other one was to determine height of approximately where this should be, and I took out about an inch worth of material. You don't want to be chopping, 3-4 inches off of this stuff unless absolutely necessary, like I said earlier, because you can imagine how difficult it would be to weld all of that back together and make it work and be strong when there's none of the original material left, more or less, and you have to patch in all that crap. So I kind of lined it up with where it should be, made sure the ram was centered in it, and just got an overall feeling that it's where it needs to be. If you're not happy with the fit up, rarely does anything get better after welding, so spend the time to make sure that this part is right, that you're happy with it. Trust me on that. You don't want to weld something in and find it's a 1/4 inch, 1/2 inch off. Then guess what? You're bringing out the torch again or art gouging welds. No fun. Don't be an idiot. I've done that enough on my own. So to start the repair, I took 1/4 inch thick steel and more or less slapped it on the sides. I also did the front that you don't see in this picture. And I TIG welded those plates basically to the packer blade. And then I TIG welded the corners of them to make them all one solid piece. Now this is more or less going to function like a backing bar to what I'm going to weld. So it doesn't really need to be that strong because what we're trying to do is tie into that decently for both what you see there and the arm that broke off. We want to tie all that together into that backing strip. And then I'm also going to plate the sides and the front of it to really make it a lot stronger than what it was. So there's no question that it's not going to break like what it did. Here's a picture showing that the packer blade base was level there, so that's a good reference point. You can see I've already welded, I don't know, probably 3-4 passes out from that TIG root to tie in that arm to the base plate. And then I also kind of, I guess, stitch welded, didn't fully weld yet, a reinforcement plate on the front side of that. So that's going to tie that arm down to the base plate. And I decided to do that just because, well, I could, and I'm not worried about it ever breaking again. Now, I'll talk a little bit about over-reinforcing things later because that's something I really didn't consider on this job. And I kind of, when I was done, had a thought like, well, if you make one side super strong and stiff, what could happen? Well, the other side will be more flexible and it might break. So you got to be careful with over reinforcing things. And realistically, I probably could have done without that plate there and let it flex a little bit more so the stress is more or less spread evenly over numerous parts of that packer blade, rather than now it's so rigid that who knows where all that stress is going to end up going. So this is kind of a bad angle, but the top was more or less level. The level isn't kind of centered on there, so if you look at the pin bores, those look a little bit misaligned. It's just where the level's sitting. One of the things you want to make sure is that rather than going off the top of it like you see here, go through the pin bores on stuff like this, because what's to say that the top's even, parallel to the pin bores? You got to be careful with stuff like that. Always reference pins for a location to be parallel to something else, because obviously that's the pivot point, so you want that to be parallel, not anything else around it. And here we go. The front side there is all fully welded with that plate on there. And then the sides I gusseted or put a plate on. And I'll talk a little bit about why I did that. But you can see everything there is kind of fully welded at this point and looking real good. Now the back side of it, I put a little gusset plate to tie in that thick steel on that base plate up to the arm. And this is one of the reasons why I believe that it failed in the first place, is that, well, for one, there was no gusset plate there, and that gusset plate is on that 1/2 inch thick steel, but the base plate there has like 3/4 or 1 inch thick steel and a couple crappy welds that kind of look like dual shield, but they had porosity, more or less tied that base plate to the arm there, and it tore through there. Well, this little gusset plate and the extra weld that ties all of that in there should be a lot stronger than what was there, and it should never fail like it did, because it'd have to tear through like an inch, 1.25 inches of steel instead of like 1/4 inch thick steel at one point. Speaking of why that failed, let's look a little bit at the design of this, and I think you guys will all have a laugh at this. So take a look at where the picture's pointing. You see how that weld kind of roller coasters down to that area and then stops? Well, that section is only 1/4 inch thick of steel, okay? The area above that roller coaster weld is like 3/4 inch thick on both sides where the ram bolts to. So that's never going to bend. And the base plate is like 1/2 inch, 3/4 inch thick steel, super beefy. So all of the stress that that hydraulic cylinder puts on that packer blade winds up hitting that little 1 inch strip underneath that weld there. There's that about 5/8 thick plate that's on the back side of there. But guess what? A couple poor welds on that, and those just cracked right through. And like I said, that whole section is only 1/4 inch thick steel. So that's why I believe that this fatigued. And once that backside broke, it just tore right through it clean like a can opener. So realistically, this is a pretty poor design, and I don't want to say that it was designed to fail, but let's face it, this is a pretty poor design, and it was going to fail eventually at that point due to fatigue. And what I find interesting is when you work on equipment enough, and I'm no expert at it, but you can see how companies will do running changes to designs to eliminate what is clearly a weak point and a warranty related issue. And this is a prime example where they recognized that they had some issues and they went back and changed it. So that roller coaster like weld had a crap ton of undercut on it on both sides. Well, guess what? They ended up doing a running change in a couple years later where they welded on a big thick plate to it. Let's take a look at that. So to take care of that crappy weld in the undercut and to reinforce that a little bit, they welded on what you see there, and that's factory. That's not done by somebody after the fact. Apparently it's factory. But I still find it interesting, if you look at the bottom of it on the right side, there's still that 1 inch gap where you're dealing with 1/4 inch thick steel that's more or less going to tear through if the backside ever tears through or the welds fail. So they didn't really change much as far as the problem. I mean, maybe in this case it would be less likely to break, but I don't know. The way that this one that I repaired in this video broke, I think would still happen to this, even with that reinforcement plate on it. So it's kind of funny that clearly they recognized they had an issue, but I don't really feel that they addressed it properly. Now, the interesting thing is I've seen other companies Packer blades, and let me show you a couple pictures of those because they're completely designed differently and arguably a smarter design at that. So here's a competing manufacturer's design, and I like it a lot better. It's all one piece. I believe it's like 5/8 or 3/4 inch thick steel, and the way it's designed puts the stress more or less in a better position, in my opinion, anyways. Now, there are limitations. Apparently, these Packer blades are known to crack in other places. It's just that the arms don't break off of them, which I don't know if they intended to have the arm break off on that one brand, and that's kind of just the design of it. Maybe it is, because like I said, I guess these are prone to bending and Ving like a plow and breaking too. So it's just that the arms, like I said, don't break off. But to me, this is a better design. So anyways, here's a finished product. The ram fit in perfectly, and because everything was aligned, because I took the time to make sure that it would work, the ram doesn't hit anything, it goes full travel, and it works exactly the way it did from the factory. Luckily, I didn't make the mistake of cutting out too much of that steel to where it would have been a bigger issue with alignment, and it wasn't damaged to the point to where repair would have been tough. And as you can see, the ram is completely in line and it's not cocked off over to the side, which you wouldn't want that because guess what? The ram would hit that and you would have all sorts of problems. I guess it's one of those things where you'd have to call in sick the next day and hope somebody else takes care of it for you, because that wouldn't be a fun repair to do. So anyways, I was going to end the video here, but I found pictures of the same Packer blade that was broken even worse, and I thought I would share the photos of it. And I didn't end up repairing this one, but you won't believe how bad a shape this one was. So we'll end this video with that. So this one, which is identical to the other Packer blade, came in on a truck and was completely destroyed. And when I say completely, every place you could find a crack, there was a crack in it. So two massive cracks on this base plate right here, and down in that little valley where that tube is, where the base plate kind of is, that weld is cracked. Literally everywhere you look, there were cracked welds on this. Base material tore right through, and that's probably at least 1/2 inch thick steel. Now this Packer blade was pretty old. Once again, it's seen a lot of life, a lot of use, but to be busted up this bad, my understanding was someone again was compressing a bunch of leaves or something like really dense and just probably kept giving it the beans. So some of this is operator error. Not to mention, I'm sure that someone noticed that things were starting to crack and then just didn't say anything, because it doesn't just randomly overnight get as bad as what this thing was. We can play a game of Where's Waldo instead. It's Where's the Crack. If you look closely at this, there's a crack that goes all the way from the lower right of the picture towards the middle of the picture and then all the way up. So all of that's cracked through, and that's some thick, beefy steel. This is the other side of the Packer blade, and you can see it's cracked all the way through there. Same thing on the other side on the far right of this picture. And I'm not joking. I honestly, I started laughing when I saw how many cracks there were. Like, you just couldn't find a place that there wasn't one. And believe it or not, the decision was made to make a repair attempt on this because of the lack of availability of parts. So it's not just sometimes a cost thing, is that you need it as a spare or to get a truck on the road, and the availability of a replacement one could be 3 to 5 months out. Well, you can do some crazy stuff like repair something like that. And a great tip for you guys that are out there fabricating and fixing junk like this, anytime you see a dark line that doesn't belong, like pay attention to what you see in this picture. Anywhere there's something that looks like a hair sitting on there, that's a crack. So that'll help you out. And if you ever see a hunk of grease and a grease has a partition in it, that's probably also a crack. So pretty good advice for you. Now, this thing being in as bad a shape as it is, clearly some negligence on the operator had something to do with why it was allowed to get this far, as well as maybe when the truck was brought in for preventative maintenance, someone missed some of the cracks that were there and it just got to the point that it is. But one of the things I noticed is this was previously repaired with reinforcement plates. So this side clearly has evidence that it was repaired at a previous time. Now, the reason I bring this up is because I kind of touched on it earlier in the video, but I'm not necessarily sold on how I repaired that one that I did as being a excellent fix-all solution. And what I mean by that is you got to be careful on things like this, where when you start making one half of it extremely strong and more or less stiff, that all that force has to go somewhere. And in the case of this, this being repaired like that may have helped contribute towards why everywhere else on it cracked and failed, and clearly this didn't really crack through. Although I do believe, looking at this picture, the top middle has a crack up into that plate and then it stopped because it hadn't torn through that yet. But anyways, what I'm getting at is you can only make something so stiff before that force, that excessive force, gets transferred somewhere else and then it breaks there. Now, don't get me wrong, this Packer blade had a really poor design to begin with, but that's based on my assumption of what they were trying to do. It's entirely possible it was designed to fail in a manner that the one I repaired did, in order to make a repair easier and to prevent failure down at different points of it, like what this one had. So I'm not really sure that I did the world's best repair on it. I know that it'll last a fair amount of time, but realistically, I should have put some gusset plates to stiffen up that other side of the one that I repaired in order to try and get it to be more of a balanced load. And that's something that a lot of us don't think of, including myself. When you do repairs like this, you're so focused on repairing what's broken that you don't think of the bigger picture. So try and think of the bigger picture, and so you more or less re-engineer things so they work for what is needed out of them and they don't fail. Because, well, when things fail and you have unreliable equipment, that's going to hurt you when you least need it to, I guess. So if you have any opinions on any of this, or you enjoyed the video, or you have questions, feel free to leave a comment down below. Thanks for taking your time to watch this video. Until next time.